Hello and welcome to lesson 8 of our set theory series. My name is J. Aquadouble and we will be looking at the Venn diagram today. Okay, so what is a Venn diagram? A Venn diagram is a diagram that shows all possible logical relations between a finite collection of different sets. And mathematically, we can represent a Venn diagram with a rectangle, and within the rectangle, the subsets of that Venn diagram can be represented by cycles. Okay, so in this case, we have the universal set, which is the rectangle and is always denoted by U, and within the universal set we have the subsets of that identical collection. So the subsets are basically represented using cycles. So in here we have two subsets, set A and set B. They form part of the subsets of the universal set. So let us see some illustration of that. So we have the Venn diagram, we have the universal set, and we also have the two sets that are within the universal set. So, and they are set A and B. Now, within set A and B, there are things that I want us to carefully understand about the Venn diagram. And they are the regions of the Venn diagram. The regions of the Venn diagram is very critical, it's very crucial that you understand the regions of this Venn diagram. Now, if you look in here where we have 1, this is a region that is exclusively members of set A, okay, but not in B. If you look here, they are in, 1 is in A, but not in B at all. Okay, so, and when you look at 2, 2 is in B exclusively and not in A. Okay, then when you look at 3, 3 is in B and 3 is also in A. So the intersection here is that the three elements here are part of set A and they are also part of set B. So they form part of the intersection. So for the Venn diagram, the overlapping section is usually the intersection. And we also have another region, which is the 4th region here. The 4th region is in the universal set, but it is neither in set A nor in set B. So what these regions actually represent. So let us find the following. A, N, that's the number of members of set B. Okay, and B says the number of members in the universal set, and C is the number of members in A union B. Okay, so the number of members in set B, what would that be? This would be equals. Let us look at B. B is here. If we clearly look here, we see 3 is in B and 2 is also in B. So the number of members that are in B will just be 3 plus 2, which is 5. Okay, so it means we have 5 elements, 5 members of set B. Okay, then the universal set. The universal set contains all of the members in the 4 regions. So we add all of the members in the 4 regions. So we have 4 plus 1 plus 3 plus 2. That will give us 4 plus 1 is 5 plus 5 is 10. Okay, so we have 10. So the universal set is actually 10. So we'll say the universal set equals 10. All right. Then for the number of members in A union B, so we will say that set A has 4 members and set B has 5 members. So you could be tempted to say 4 plus 5 is 9. But no, it's not that. Because we have 3 members here that are common to the both sets. And what we usually know about sets is that no one single member appears more than once in a particular set. So if you were to say 9 members, so what you will be doing is to repeat 3 twice in that identical union set, and which of course is not the case. So 3 will be represented once. So it means you have 1 plus 3 plus 2. So you have 1 plus 3 plus 2, which is 6. So we have 6 members in the union set. Okay, so we also have the universal set, and this time around the universal set is 30. Okay, so we have the 2 interior sets, which are set N and set M. Okay, so we have 4, 1 or 10, and X, and 5. So the 4 regions are occupied by the respective elements or number of elements. Okay, this is not member 4. No, the 4 here represent the number of members in this identical region. So let us clearly understand that the Venn diagram actually talks about the number of membership. Okay, so with this, let us find the following: the number of members in N, and number of members in M, the number of members in N intersect M. Okay, so what we will do here is, in order to find any of these members in these sets, what we will want to do is to know the value of X. Okay, so how do we determine the value of X? Now, the universal set is 30. Okay, and what we know about universal set is the universal set is a sum of all of the members that are under consideration for that identical context. Okay, so it means we add all of the members in the respective sets or these respective portions of this diagram will constitute the universal set. So since we have 30 as the universal set, we say 30 is equals to the sum of each of these members, each of these numbers. So we have 5 plus 4 plus X plus 10. Okay, so we will use that equation to solve for X and know what value of X is at the intersection. So we have 5 plus 4 is 9, 9 plus 10 is 19. So you have 19 plus X. Okay, so we definitely have X equals, the 30 is here. Okay, and we transpose the 19, it becomes minus 19. Okay, so we have X equals 30 minus 19 is 11. So the value of X is 11. So at this intersection, we have 11 members. Okay, so then the number of members in N becomes N. We have 4 in N. We also have X in N. So it means 4 and 11. So we have 4 plus 11. Okay, so that will give us 15. So we have 15 members in set N. And set M, so we have equals, we have 10 in M. We also have X in M. So you have 10 plus 11. That will give you 21. So we have 21 members of set M. And the number of members of N intersect M. So that becomes, if you look at the diagram, N intersect M. The common region to the both of them is X. So X is 11. So it means we have 11 as the number of members at the intersection. Okay, so let us see another problem. There are 20 members in our music group, 15 of whom can dance, 5 can sing and dance, while 4 can neither dance nor sing. How many of our members can A, sing, B, sing but can't dance, and C, neither sing nor dance? Okay, so to solve this problem, we are going to use the Venn diagram. So in using the Venn diagram, the first thing we do is to draw our rectangular shape, which represents the universal set. So we draw our universal set, and we also draw the sets that represents the subsets of that universal set. So if you look at this problem, we have two subsets of this universal set. In the set of 20 members in the musical group, we have some can sing and we have some that can dance. Okay, so the two subsets of this universal set are the set of singing and the set of dancing. So we say this will represent the set of singing, we say S, and this the set of dancing, we say D. Okay, so the next thing to do, so we know definitely that this is the universal set. All right, so the next thing we will want to do is to narrow down this this sentence into mathematical representation. So we will do that, and we say there are 20 members in our music group. So the music group is the universal set. So it becomes the universal set is 20. All right. So then 15 of whom can dance. So the number of members in the dancing group is 15. And 5 can sing and dance. So 5 can sing and dance. So these 5 are formed in a set of singing, and they are also formed in a set of dancing. So it means they form the intersection. So they are at the intersection of the both sets. So we say the number of members of N S intersect D is 5. And 4 can neither sing nor dance. So these 4 are formed in none of the subsets, but they are in the universal set. All right. So after that, what we will do is to transfer these values into the Venn diagram. And how do we do that? The key thing is this, that you always begin from the intersection and go outward. No matter how many subsets, begin from the intersection and go outward. So the intersection here is 5. We have 5 members in the intersection. They are formed in S and also formed in D. So if you look here, this region is formed in S and also formed in D. So we have 5 members. So we put in our 5 here. Okay, then we go to the next one, and that is the number of members in D is 15. So if the number of members in D is 15, but we already have 5, because these 5 are part of D as well. So it means we have 10 more members adding up to this 5 to equals to the 15. So we have 10 members outside of here. So 10 plus 5 is 15. So these are the 15 members in D. Then the number of members in the universal set are 20. All right. But one thing we also understand is there are 4 of these members that are in none of the sets. So but they are in the universal set, of course. So you have that 4 outside of here. This 4 is in the universal set, but it is neither in S nor in D. All right. So if the universal set is 20, so what we will want to do is to compare the number of members already in the universal set as written to that of the 20 value. So you have 4 plus 5 is 9, 9 plus 10 is 19. So it means we are still left with one more member. And where would that one member be? And we have one region that do not have any membership. So it means that one member is at that region. So we have one member here. So if we add all of these members in here now, it will give us 20, which is the total number of members in the universal set. Okay, with that, all of the regions have been occupied. Then we come now and solve our problem. A says sing. Okay, so the number of members that sing. So you go straight in the set of singing. If you see in the set of singing, we have the 1 person here, and we also have 5 person here that can sing and dance, but they are in the set of singing. So we have 1 plus 5. So the set of singing, the total number of members in the set of singing okay, will be equals to 1 plus 5, which is 6. So we have 6 members in a set of singing. Then the number of members in D, okay? Oh, sorry. Then the number of members I can sing but can't dance, okay? So it means the number of members in the set of singing I can't dance. So it means this portion is actually S minus D, okay? So you have the number of members that are in S minus D. Okay, if you can still recall, in our previous video we talked about the difference of two sets. The difference of S minus D is all the members that are in S but not in D. So if you look here, all the members that are in S are not in D. It's just this portion, this region. So you have 1. So we only have 1 member that can sing but cannot dance. All right. Then the last one has to do with neither sing nor dance, and that is actually given even in the problem. We have 4 can neither dance nor sing, but yesterday you can have it here. This 4 is neither in each of these sets. So we have the number of members in the universal set but not in these two sets will definitely be 4. Okay, so thank you and see you in the next video.